Guys, we're back with a LeetCode problem. I haven't done a LeetCode problem in a long time, but I was bored and I was like, I might as well just do this problem. So we're going to do this problem. I like this problem. It's a lot like number of islands. I solved that on this channel a long time ago, almost half a year ago. So now we're solving max area of island. So let's do it. Okay. Now, in this problem, we are given an m by n binary matrix grid. An island is a group of ones representing land connected four directionally, horizontal or vertical, which means that this right here, these two blocks do not constitute one island because they're connected diagonally. Now, you may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with a value 1 in the island, okay? We want to return the maximum area of an island in grid. If there is no island, return 0. Now, this just gives a bunch of examples, but the important thing here is to note that this is basically our input, and if we represent that as a grid, we get that, right? And we want to find out the maximum area of any one of these. And of course, if you go and count it out, it's 6, which is this particular one. Okay, now our solution is going to involve, is going to use depth first search. So what we're going to do is we're basically going to iterate through this grid. And at each particular square, we're going to be checking if we're on an island. And if we are on an island, we're going to count how many ones are in that island, how big that particular island is. And then at the end, as part of when we're counting, we're just going to keep a maximum variable that's just going to change based on whether or not we found a bigger island in that particular call to the depth first search function that we're going to be writing. Now, it's going to make a lot more sense when I implement it, so let's get right to the implementation. The first thing I'm doing is I'm creating a visited set, okay? And the reason why I'm creating a visited set is because each time we get to a square, it's going to be particularly useful when we're on squares with islands. We want to know whether or not we've already visited that square in a previous call to the depth first search function that I'm about to write. Because we don't have to do it again because we already know the size of that island if we've already visited it before. Now, not only that, but it's going to allow us to not visit the same square twice on the same stack of calls to our depth first search function so that we're not counting one square twice when we're counting the area of an island. Okay, so we create that visited set. Now, the next thing we do is we're just going to create, we can do this lower in the code, but I'm just going to do it now. We're going to create a variable to max, set it equal to 0. This is going to contain basically the size of our biggest island so far. And of course, right now it's 0 because we haven't done anything yet. Now, what I'm going to do is I'm just going to get the height of the grid just so I don't have to type length grid out all the time. And I'm also going to get the width of the grid just so I don't have to type out length grid 0 all the time, right? That's easy. Okay, so now we're going to write our depth first search function. We're going to define depth first search. We're going to take the grid as an input. We're going to take I, and we're going to take j as well. Now, what I and j are, essentially, I guess we don't even need to take grid as a parameter because we have grid here. So we'll just take I and j. Now, what I and j are is they essentially represent where we're at in that particular call to depth first search. Now, if we're outside of the boundaries of this grid, well, we can just stop, right? We can just return 0, and I'm going to explain a little bit later what returning 0 means. But what that means is that the first step in anything is to just check whether or not we're outside of the grid. So we're going to just do if I is less than 0 or I is greater than or equal to height, or j is less than 0 or j is greater than or equal to width, we're going to return 0. Okay. Now, we want to return 0 then, but we also want to return 0 if the square we're on right now has already been visited, right? So what we're going to do is we're going to say if ij, and you notice that's a tuple because we're going to be storing tuples in this set. I'll explain that a little bit more in a second. If ij in visited. Now, there's one more situation where we want to return 0, and that's, of course, if we are on a square which has a value of 0, and that's because we're on water, right? We're going to return 0. Okay. Now, what does this return 0 mean? All it means is that we do not want to return something up the stack to the previous call to DFS because this is going to be recursive. We do not want to return the number 1 because if we return the number 1, that means we have found a square that we want to add to the area of our island that we're counting in that particular stack of calls to this DFS function. Okay, so we're returning 0 in all these situations that I'm outlining here because we're on a square or we're outside of the grid or whatever, and we don't want to return 1 up the stack to our previous calls. Okay, now what we want to do is we also want to add the tuple of I and j. The reason why we're using tuples is because a set here, you can't have lists in a set. You need to have tuples because tuples are hashable in Python. So that's why we're using tuples. So we want to add the tuple to our set just so the next time that we come through this DFS call, excuse me, we can see that we've already visited, and of course we can return 0 from that call. Now that's great. Now if we get through all that, right, we haven't returned 0. Well, we want to return 1 plus DFS of I plus 1 j plus DFS of I minus 1 j. We'll start a new line here. Plus DFS of I j plus 1 plus DFS of I j minus 1. Now, what this is doing is essentially saying, okay, we found 1, so we're returning 1 plus however many we get out of the calls to the DFS function on the 4 squares surrounding it, right? So this would be the square to the bottom, I believe. This would be the square to the top. This would be the square to the right. This would be the square to the left. Okay, and if these all return 1, then we're just going to add these all up, and by the time we get back to the bottom of the stack, we have our number of how many actual squares are in that island. Okay, so now what we want to do is we want to iterate through all the squares in the grid, and then we're going to call this DFS function on each square that we're at, and we're going to check whether or not it's greater than our maximum. So we're just going to say for I in range height, for j in range width, and of course we do height and width because we already set them up here, and we want to iterate through both of them in a nested loop because that's how we iterate through a grid. That's just the only way to do it. Nested loops, sometimes they're necessary. In this situation, it is necessary. So what we want to do is we want to set the max is equal to max of DFS of I and j, or the previous max, right? Whatever the max was before. And then after we write that code, we can just return the max. Okay, now let's run our code. Let's make sure we're correct. And we are. So that's how you solve that problem. This one's I enjoyed solving this problem. I like depth first search. I've always thought it was a cool algorithm. So yeah, there's another LeetCode problem. I haven't done one in a while, like I said. Thanks for watching, guys. If you like that, like, subscribe. See you next time. Take care.